Hi, Contact Dev here. I'm a senior software engineer with a decade of experience, and I've done substantial testing work from anything from my small apps to large-scale deployments. Now, in this video, I'm going to talk to you about how large software companies test their products, and on top of that, I'm going to give you examples of how I do my own testing, including manual and automated testing. Finally, I will top that up with a real-world example of how I push one of my apps, starting with a feature idea, all the way down to the mobile phones of the people who are going to use that. Now, quality is the essence of software development. If your software doesn't function as it's intended to, there's no value in your work. So how do you ensure the value of your work? Well, you test it against all the requirements. Now, for example, say you have a game that works on mobiles and the web, and that game has a feature of saving the progress after the user exits. Now what do? You test it on the mobiles that you want it to work, Android and iOS, and you test it on the web browsers that you want to support. Obviously, every feature that you add will add to your testing workload. In these sort of situations, test automation is your friend. If you have automated tests that test your app against all requirements, you can rerun those tests under different machines, under different mobile phones, different browsers, and ensure the functionality. But do not forget, simulation is not real-world testing. As much as you depend on automated testing, you will need manual testing to ensure mobile app or whatever you are developing functions as you intended to. Now let's start with automated testing strategies. First and foremost, the most important testing strategy is test-driven development. Now, what is test-driven development? It is the art of writing tests before the code. Now, why do you want to write your tests before the code? Say you are developing a small feature, something that prints the date on the screen. Now, what do? You code something, you execute it, and verify that it works. So you are basically testing your code right after writing it. Instead, you can write the test before the code and execute that test against that function and verify that functionality. Now, creating a feature in read, eval, print loop is pretty inefficient. You know that, I know that, but we do it because it's the most straightforward way. If you change your thinking and start writing the tests before the actual feature, you will see that you can use that test to replace that ripple loop. Now, how do you go about doing test-driven development? It is easy. You start by defining the highest level of functionality of your app in tests. Once you do that, you will be able to assert the highest level of requirements for that app. Now, writing tests before the code in this manner does not feel like a chore. It feels more like creating a design document that will validate your ideas. And you can reuse that code, which is your design document, over and over as your software changes. While doing TDD, you use three kinds of testing. First, unit testing. Second, integration testing. And third, end-to-end testing. Now, don't worry, I'm going to explain those concepts in a moment. As a special note, I should say, if you are doing TDD and you find a bug in a piece of your app, you create a regression test that replicates that bug. And you go fix that bug and then run that replication test to verify that the bug is gone and won't happen in the future. Also, when you add a new functionality, you create a new test. When you make a design change, you go ahead and change that test also. Don't forget, in TDD, test code and your software lives and dies by each other. Test-driven development works best with dependency injection pattern. To learn more about test-driven development and dependency injection, check my video on software principles and practices. The link is in the description below. Now, as I said, let's open up the three main testing categories a little bit. First, unit test. What is a unit test? Well, as the name implies, it is the smallest possible test you could write, testing the smallest possible functionality provided by your software. Now, if you are doing object-oriented development, the smallest possible functionality would be a method in a class. So you go ahead and write a test that verifies the functionality of that method, which would make that test a unit test. While doing unit tests, you don't test the integration of functions and classes with each other. Rather, you want to test each function in isolation. To be able to do that, you use methods like dependency injection, mocking, etc., which I will get to again. As a side note, writing unit tests after the software is written is pretty much useless in my opinion. You would much rather write integration tests or end-to-end tests after your software is complete. On the other hand, if you are a junior developer or you are hiring a junior developer, it's an exceptionally good way to make them write some unit tests, even for the existing code, to help them learn the functionality of your software. 2. Integration tests. What are integration tests? Now, they are the tests that test the integration of different parts of your software, just to make sure that they play along well with each other. Now, say that you have a small web service that returns the current date based on your location. To be able to do integration tests against it, you want to deploy it, you want to execute some requests against it, and you want to verify the return values from that service. Now, as I said, it is really good for multi-component software, especially to be able to test that those components act nicely together. It is also really good for web services because you can not only test the web server itself, but you can also test the client SDKs that you write for that web service. Personally, integration tests are the kind of tests that I use the most because of the client-server architecture of most of my projects. Unlike unit tests, integration tests exercise the software in real-world situations. Even if you are not doing test-driven development, I highly recommend you write integration tests. They will pay off in no time. 3. End-to-end tests. What is an end-to-end test? Now, say that you have a mobile app and you have deployed it to your mobile phone already. Now you go ahead and test it manually, which is an end-to-end test. However, you can automate it using mechanical clickers, which would be an automated end-to-end test. However, if you don't want to use a mechanical hand to automate your testing, you can use an end-to-end testing automation library. There are some really great automation libraries out there. Selenium, if you are a web developer, Appium, if you are a mobile developer that does hybrid apps, and the native end-to-end testing libraries provided by pretty much any system vendor. Now, you have your end-to-end tests and end-to-end automation framework set up. You can go ahead and execute those tests against a simulator or a real device that is connected to your computer. Alternatively, you can use a device farm. Now, what is a device farm? Well, if you have more than one device, it becomes a farm. You don't grow them, but you use them for testing. You can have 100 phones connected to your computer or local network, and you can try them remotely, or you can use a cloud service provider that does this for you. Good examples are Firebase Test Labs by Google, AWS Device Farm by Amazon, and Visual Studio App Center by Microsoft. And finally, the Sauce Labs, probably the biggest and most complex of them. Now, if you are curious as to how a device farm physically looks like, here's a photo. Cloud device farms are useful, but they are limited, so you should consider that. Also, not all of them support all of the automation frameworks, so you should choose one according to your framework. Most of them provide free trials, so you can go ahead and try them, and I will put the links in the description. After all these levels of testing, if a bug still persists, you can safely claim that it's not a bug, it's a feature. Now, final staple of automated testing is continuous integration. What is continuous integration? It is continuously compiling and putting your software together and executing your tests against that compiled software. During continuous integration, you not only compile and link your software, you run static code checks against it. You run style checks against it. Now, you can do continuous integration locally on your machine, or you can use a CI server. My personal favorite ones for local CI is Jenkins, as well as homebrewed Docker solutions. If you want something hosted for you, you can use Travis CI, you can use Circle CI, you can use GitHub Actions. In this manner, you can get every single commit built and verified before being pushed to master. If you want something more powerful and more customizable, obviously Amazon, Microsoft, Google, all of them provide custom solutions to host your code and build them in a CI server. Those cloud providers either provide free services for open source or free trials for proprietary apps. I'll put the links in the description and you can go ahead and check them. Now, bugs age like cheese. They stink. Automatically compiling your software and running tests after every commit helps you find these bugs early so they won't stink. Now, the almighty and all-dreaded manual testing. Now, manual testing starts with a code review. What is code review? It is getting one of your peers to proofread your code. Then you will get to modify it and finally merge it or close it. You're gonna say, this isn't exactly testing anything, but it is so fundamental that I had to mention it. Here's what a fully qualified pull request in GitHub looks like. Check out this screenshot. A quality pull request will have multiple thumbs up by multiple people. It will have comments and reviews by multiple people. And it will have successfully built by a CI and will be ready to merge. Peer reviews are like proofreading. Your code might compile, the test might pass, but it might still have deep down issues. Having another pair of eyes to have a look at your code will help you a lot with those issues. Device testing. What is device testing? Device testing is the act of eating your own dog food. Say you have a mobile app, you use it on your phone. Say you have a program, you run it on your computer. Say you have a web service, you use it. Say you have a game, you play it and enjoy it. It is the simple act of eating your own dog food. In large enterprises, you will be provided with hardware, computer, phone, etc. And you will be asked to use that enterprise's apps on your phone, programs in your computer, and will be asked to use their web services, which is a really good way of testing. On top of that, larger companies will have device labs. Now, what is a device lab? Check out this photo. In its simplest form, a test lab is a room full of different devices. You take your program and you test on those devices. Large enterprises, or you alone, can also use device farms in manual mode. A lot of device farm providers give you the ability to use the farm in a manual mode. That means you can fire up a device, real or simulated. You can load your app, attach a debugger, and use it as if it was right next to you. You need to test your programs on various devices, possibly all device variations that they will run on. At the end of the day, it doesn't matter if your program runs fine on your machine. You won't ship your machine. Now, talking about large enterprises, big companies will have dedicated quality assurance departments. Now, what is a quality assurance department? It's a department of people which are specialized in testing their own software. Now, most enterprises use this as this primary means of testing. On top of that, they will ask their own developers to test their own software, which is really good. Say that you have a very large software that you are creating. It has a front end written in React, it has a back end written in Go, and it has SDKs that provide the communication with the front end and the back end. Now you have 3 teams developing each of them. They won't really know how other parts might work, but if you assign one of the back-end developers to front-end testing and take one of the front-end developers, assign them to back-end testing, they will have a chance to learn other components of their software. Now this creates a synergy between the teams. Not only that, it gives people in those teams mobility. Say you want to change your job from front-end to back-end, you know the software now, you can do it. So using your own devs as your testers is really good value. Now finally, outsourcing. Q&A departments outsource their testing quite a bit. They outsource to China, India, or wherever testing is cheap. They also outsource to contractors, which is really good actually, because it provides another fresh set of eyes to look into your apps, test in a ways that you might not have imagined. It generally yields pretty good results, in my opinion. Big enterprises like Microsoft have been migrating to automating testing for quite a while, but that doesn't mean that manual testing isn't important. It is still as invaluable as it has ever been. Big projects that interact with many hardware and software will have to depend on manual testing a lot. A great example is the Linux kernel itself. Now, final step of testing: alpha and beta programs. What is an alpha and beta program? It's basically creating pre-releases of your software. Say you have a bunch of developers, you assign them as their alpha testers, and say you have some early adopter customers, you assign them as their beta testers, and you keep releasing to them. So they will test your app, pre-release, and give you valuable feedback. Your developers will enjoy testing latest and greatest apps. In addition, customers love beta programs too. They get a chance to influence the features that will make into the release, and they will also provide valuable feedback, which will in return help them. Personally, in my apps and services, I employ voluntary testing. I create a subreddit as the testing subreddit, and I create a beta or alpha channel in the App Store that I'm publishing my app. And people naturally sign up, say 1 to 2% of them, and they provide really good testing value and feedback. And as the grand finale, I'll give you an example of how I deploy one of my apps from a feature idea all the way to the release. Check it out. Real world example: Crowner. Crowner is a game that I created several years ago, and it is currently available on Android. I'm planning to make it available for web and iPhone next year also. Now, here's a small gameplay intro. In this game, you are a king. You lead your nation, and you try to keep a balance between the public opinion and your finances. Game controls are quite simple. You are given 2 choices, and you have to choose the best one for the circumstance. You will get into many adventures, you will get into a lot of dangers, and you will try to dig yourself out of them. While doing all of this, you will live the life of a king, a medieval king, and you will either succeed or die trying. Your legacy will be remembered, and your heirs will take on from there. As I said, it's available on Google Play Store. You can just go ahead and check it out. I'll put the link in the description below. I host the source code of Crowner in a GitHub in a private repository. And for each release, I prepare a pull request. In every pull request, I try to improve the story a little bit and also add some gameplay elements. As you can see in this pull request, I'm working on the iOS app. I have some gameplay and story improvements. In my pull request descriptions, I like to keep a list of items that I'm working on in this pull request. I also like to reference the actual issue that task points to. Every time that I make a commit to that pull request, it gets built by Travis CI. Travis is my choice of continuous integration server, but you can use pretty much anything with GitHub. At every commit, the game is built and the automated tests are run on it. Now let me show you how those automated tests are running. As you can see in the example, the game is being played at an extreme speed. For almost 30,000 rounds of gameplay is being done. After the gameplay, I look at the statistics of how successful random choices were and compare that to previous gameplays and try to average them out and make sure that they are within the sensible limits. I also make sure that there are no errors during the gameplay, no crashes, and everything goes smoothly. In the future, I intend to incorporate some machine learning into this test, so it will try to get better and better at gameplay at every play, and then I can measure its performance against actual human players. These tests run after every commit, but I also run them on my computer before a major release. After the test is finished, the game is automatically uploaded to Google Play Store. And once uploaded to Play Store runs automated tests on it again. As you can see in the screenshot, it looks for crashes, compatibility issues, it looks for performance and security issues, and accessibility. You can go ahead and check out the tabs to get the details on the stability and performance reports. Let's check it out. When you click on the Performance tab, you see the game runs on various devices. Play Store employs a very simple testing methodology. It randomly clicks on the screen until your app progresses. And during that, you obviously consume some resources, CPU, RAM, etc. And at the end of the test run, you get a nice graph like this, and you can see if your app is problematic on some of the devices. This is extremely useful, and I highly recommend anyone to enable the automated test runs in Play Store settings. Once the automated tests are complete, I go to the app releases page of Play Store and verify that Fresh New Build is in the alpha channel. Once it's in the alpha channel, all the alpha testers, including me, gets the app within an hour, and everyone, including me, tests the app on their phones. If it was a major release, I do a couple of hours of gameplay. If it was a minor release, I do a quick skim through the UI. Once the alpha testers give it a go, I either release it to beta or production. People who receive the app through the beta or release channels can provide their feedback on Play Store beta channel or on Crowner subreddit. If all the feedback is good, or if there is no negative feedback, I release the game to 100% of the players. Crowner is an amazing game, and go ahead and check it out on Android Play Store. If you have an iPhone, or if you want to play it on the web, I will be releasing them by next year. And this is a simple and streamlined process to releasing an app. If your app is simpler, you can eliminate some of the steps that I've described here, but for most people, this is the golden standard of releasing an app, or just about any web service. After all this information, if you still do not test your product, your engineering manager will fire you, and you will find yourself honestly thinking,
Hey, you. Finally awake.